Alright, in this class we're going to be doing day 3's homework. Day 3's homework has a lot of fractions in it, so we may sidebar and review those skills. So we're week 2, day 3 now. Okay, so 1/2 x plus 1/3 x minus 1/4 x. Okay, so everything's adding and subtracting, they're all like terms. So now I just need to get a common denominator. So the common denominators of all of these fractions would be 12. Okay, so I have to multiply this one by 6 to make the bottom 12, this one by 4 to get that bottom 12, this one by 3, and I got it, whatever I do to the bottom, I have to do the top. So that's going to make this one a 6 over 12, a 4 over 12, and a 3 over 12. All right, now remember, I only have to do the coefficients, so I only have to add and subtract these fractions. So 6 plus 4 is 10 twelfths. And then if I minus 3, I have 7 twelfths over x. 7 twelfths x. And that does not reduce, so I'm done. Let's do number 2. So now I got to multiply this fraction by everything on the inside. So 2/3 times n is going to be 2/3 n. Drop down that addition. And then I'm going to do 2/3 times 6. Now remember, I got to make it a fraction. So I'm going to make it a 6 over 1. That's how I turn a whole number to a fraction. All right, so multiplication first. 2 times 6 is 12. 3 times 1 is 3. And that is actually going to reduce down to a 4 because 3 can go into 12 4 times. Okay, so my ending resulting expression is going to be that. All right, next one is a big one. Okay, so this is number 3, and it's probably going to take up this whole screen because it's fairly big with some complicated fractions. All right, first thing I need to do is my distributing. So I'm going to take -2 times everything on the inside. So -2 times the x, drop down my plus, -2 times the 4. Now I'm going to take a -2/5 through this one. So -2/5 times the x, drop down my addition, -2/5 times 5. All right, let's clean this bad boy up. Got to put ones underneath my whole numbers. So -1/2 times x is just a -1/2 x. Don't overthink it. This one, if I multiply across, I get 4 over 2, and it's going to be negative. Again, don't overthink it. 2/5 x. Drop down my positive. Okay, so now if I do this, it's going to be 10 on the top. 5 times 1 is 5, and it's going to be negative because I have a negative and a positive. Let's clean up these signs. So that's going to be a -4/2. You don't have to clean up the signs unless there's double negatives, but I'm going to anyway, just so it's cleaner. All right, so this term is like with this term. So I'm going to rewrite it so that my like terms, wait a minute, yeah, they are like, but I forgot my x. All right, and then this term is like with this term. So that helps to get it down a little bit. All right, so the common denominator of everything here is 10. Okay, so I'm going to just change my fractions. If you're having trouble with this, you need to watch a fraction video. Don't have one currently. I'll put one up on the page. All right, So now all my fractions are good to go. These two are alike, so let's combine them. Negative 5 minus 4 is a negative 9/10 x. And now these two, because they're like, negative 20 minus 20 is going to give me a negative 40/10. Don't say 0 because they're both negative, which means I add them. All right, so let's clean this up because I can take 10 and divide it into negative 40, and my answer would be 4. If 10 goes into 40 4 times. All right, let's do the next one. How many do we have in this set? Looks like we have 9. So now we're doing number 4. Okay, and it says write this in a word phrase, okay? So I like to start with whichever one does not have a variable. Not technically wrong if you don't do that. That's just my way of doing it. So I'm going to put 18 in a word that means addition. I'm going to use added. Doesn't matter what word of addition you use as long as you do a word of addition. And then I'm going to put 43. I'm going to put times. You could use multiplied. You could use by, of, any word that means multiplication. Okay. So it's just easy as that. That one was just straightforward, go across. Number 5, 22 divided by r minus 37. I like to use the whatever term does not have a variable. I like to go first. So 37, it's less, and I need to have it turn about. So I'm going to put less than 22 divided by r, divided by r. Okay, again, you can write it different ways as long as you get the right operational words in there. Okay, number 6, now we're going to do some reasoning. So write 2 different algebraic expressions for 5 less than the sum of x and 7. Okay, so the sum of, right here means parentheses with addition, and then x and 7 go inside, and it's minus 5. So this is the typical way. After I look at it though, I can see I don't really need the parentheses because there's nothing to multiply through. So all I can drop them because I need to add the 7 and subtract the 5. So the other way I could write this is this. And what I want you to do is start seeing when do I need the parentheses. Just because it's written so that you need a parentheses doesn't mean you actually need it. All right, let's do number 7. A student wrote an algebraic expression for 5 less than the quotient of n and 3. He wrote it like this. What? Oh, the A is not part of it. What did they do wrong? Okay, what they did wrong is 5 less than, okay, is a turnabout. All right, so if I have 5 less than, that goes to the end of the expression. So the first thing I need to look at is the quotient of, which I know is parenthesis, n and 3. I have to do this first before I can subtract the 5. What this is saying is subtract the 5 from the n, then divide by the 3. That's not the order I want to do it in. I want to divide the n by the 3, then subtract the 5. Okay? So it's very important that I write it this way. All right, so 2 more questions. Okay, number 8, which expression means 3 times the difference of y and 4? So let's just go ahead and do this expression, write it out, and see which one is the closest. So I know that this means parentheses, difference means subtract. What comes after goes inside the parenthesis. 3 times just means 3 times it. I could put it out, but I don't need it. And as you can see, C clearly states that. All right, let's work on 9. And this was our reach question this week. A company prints N books at a cost of $9 per book. Okay, write an expression to represent the total cost of printing the books N. That is the total cost of 150 books printed. Okay, so the first thing I need to do is write an expression, okay? We need to write an expression. All right, and this is kind of like the problem in the last set where you could do it as addition or you could do it as multiplication, but if I want to write an expression, I want to do it in multiplication. So it says that I can print N amount of books. I'm unaware of how many books that I can print, but if I times 9 by that, okay, then I will know how much it's going to cost, right? So that will give me the cost of printing books, because it costs $9 per book, and I just need to insert how many books I'm going to print. Okay, so I have my expression. The second thing is I need to evaluate, which is, this is why it's our reach question, because we haven't really learned how to evaluate, but I want to see if you can use the word clues to do that. So it says, what is the total cost of 1,050 books are printed? So that's the amount of books I'm printing, so it's going to be evaluated for N. I'm going to substitute it in for N. All right, and if I multiply that, I get $9,450. That's how much it would cost to do that many books. Okay, so if you have any problems with any of these questions, contact me and I'll try to help you further. Other than that, I'll see you in our next class, and we will be moving on to evaluating expressions, doing what we did in this number 9. All right, see you in class.